So we are now doing our multi-step equations. Okay, our multi-step equations. There's going to be more things going on. They're going to be more complicated to look at. The overall step you're doing is the same as yesterday, though, okay? That you first combine any like terms you have to do on either side. You first do distribution on either side. You have to get those things cleaned up and simplified. Then you go ahead and move the smaller variable to the larger variable and get your zero pairs, your big zeros, okay? This is our big zeros, okay? That's what they're talking about, zero pairs. This is the big zero, okay? And then we do the opposite operation, just like yesterday, which the official name is the inverse operation. And that is getting us big zeros and big ones. Oops, the R's missing. Okay. So the process is still the same. It's just the problem you're looking at is going to have more in it. And then we're going to check our answer. Okay, no big deal. So remember, in the chat is where you show you're participating, so you can get some of your participation points. Okay. So we need to get our equation, our first equation we're going to work on. I'm going to be blue writing for equations today, just to change it up. Okay. Now, our first equation we're going to be looking at is 5x plus 2 minus 2x plus 9 is going to equal 3 times the quantity of 2x plus 5, and then minus 6. So see, it's just more complicated looking. It's not more to do. Okay, it's not different process. So first part of the process, we make sure that we have combined like terms where we can. Okay, that's our first process. So does one of the sides have some like terms we need to combine? Does one of the sides have more than one x showing, more than one number showing? It's more complicated than it needs to be. Do we have that happening? Do we have one of the sides that has more than one x showing? More than one number showing, so we have to clean it up? More than one x, yeah, more than one number on the left side. So the left side is being complicated and it doesn't need to be. Okay, left side is being complicated, it doesn't need to be. So we're going to go ahead and clean up the left side first. We're not going to worry about the right side yet. We're going to worry about our left side first. So I need to combine like terms. So we're going to go highlight the things that are considered like terms. Okay. I found that using the box highlighter works better. And I'm going to use bright pink for one of my colors, and we use bright green for the other. Okay. So pink, no, bright pink. Like terms would be the 5x with the negative 2x. That's one set of like terms. Okay. The other set of like terms is the positive 2 with the 9. That's not bright green. Let's see. I want a bright green, huh? want it to show up, not just look gray. Okay, it's a little better. Still, you know, kind of grayish to me. Okay, so I need to clean those up. All right, we need to clean those up. So the first thing I need to do is look at the x's. Are those x's the same sign? Are those x's the same sign? That says 5x, that says negative 2x. Are those the same sign? No. Okay, so if those are not the same sign, then what are we supposed to do when we combine them? What math operation are we supposed to do? When they're not the same sign, what math operation are we supposed to do? When they're not the same sign, what math operation are we supposed to do to make them come together? Subtracting. And then after we subtract, we find the sign of the final answer by looking where? Find the sign of the final answer by looking where? At the bigger number. So let's first think about the sign. What's the final answer sign going to be? Who's the bigger one and what's his sign? We are looking at 5x and negative 2. So who is the bigger one? 5x is bigger and he's positive. So my final answer is going to be positive. Positive what? Positive 5x's minus 2x's. What are we going to get? 5x's minus 2x's. What are we going to get? 3x. Now we look at the numbers. We have a positive 2 and a positive 9. Are those the same sign? Are those the same sign? Yes, so we just do what it says. Positive 2 with positive 9 makes what? Positive 11. Don't forget signs. Don't just say the number, even though we know that when we just say the number, we mean positive. We are building an equation, so we need to make sure we put that positive sign in there, okay? Now we have to go work with the other side, and that's to use the distributive property. Use the distributive property. Now, when we use the distributive property, what does this 3 on the outside really mean? What math operation does that 3 on the outside really mean? What math operation does that 3 on the outside really mean? Multiplication. And it means multiply both pieces, not just one, both of them, okay? So we're gonna put our rainbow in. I switch to my pen and I'm gonna connect my 3 to my 2x and my 3 to my positive 5. To remind myself, I have to multiply both of them times that 3, not just one or the other, but both of them. So if I do a 3x times a 2x, what am I going to get? 3x times a 2x, what am I going to get? I'm going to get a 6x, yes. And then I have a 3 times a positive 5, so I'm getting a positive, right? Positive what? Someone else other than Lily. 15. Okay. And then did I do anything with that negative 6? Did I do anything with that negative 6 yet? No, so negative 6 is still there after the 15. Okay. I notice I have to combine like terms on the right-hand side now. I'm not changing the left side, so 3x plus 11 is still there. Some of you need to look at your private chats. I'm having a conversation with you and you need to respond back. Okay, I still have the 3x plus 11, but I need to clean up this side. So I need to combine my like terms. So let's see what I have to combine. I have to combine a number, so that's the green. I have a positive 15 and a negative 6 I need to combine. Am I doing anything with the 6x? Do you see, did I highlight anything to go with the 6x? Because there was another x? Did I highlight anything to go with that 6x? Because I would have highlighted another x if there had been another x, right? So do I see another x on the right-hand side? No, that's why it's only 6x and I didn't change anything. There's no change going to that one. But the other one says a positive 15 with a negative 6. Are those the same sign? No. So we subtract and keep the sign of the big one. What's the sign of the bigger one? What's my sign on my bigger number? We're over here on the positive 15, negative 6. What's our bigger sign? Positive. Okay, and then 15 take away 6. Positive, and then 15 take away 6. Positive 9. Okay, now that it's just two things on the left and two things on the right, we are done with number 1. That is all number 1, okay? So now we're looking at number 2, which is smaller variable moves first. So look at our x's. Look at our x's. We have a 3x and we have a positive 3x and a positive 6x. Which of those is the smaller number? Which of those is the smaller number? Which of those is the smaller number, 3x or 6x? 3x. So we have to move the 3x by doing the opposite. We're making our big 0 now. We're making our big 0. So what do I need to do to turn that 3x into the big 0? What do I have to do to turn that 3x into the big 0? How could I turn a positive 3x into a 0? What am I going to combine on both sides so that the 3x becomes 0? No, we're not dividing because dividing does not make a 0. How do we make the big 0? Subtract 3x, not just 3. So make sure you're saying 3x because the number 3 and a 3x are two different things. 3x is 3 times something. 3 is just 3. Okay, so we have to subtract the 3x from both sides of the equation. We have to subtract our 3x from both sides of the equation because whatever we do on the left, we have to do on the right. We have to keep the balance. We have to keep the balance. So my 3x minus 3x, there's my big 0, so I can cross him out. That's 0. What's left on the side over here? What's left on this left-hand side? If I get rid of the 3x, what would be left behind? The 11. Okay. number equation. 11 has to equal. Then I have to solve this 6x's minus 3x's. What do I get? I have to solve this 6x minus the 3x. So what do I get? $3x, okay. And I still have that add 9 going on. I still have that add 9 going on. Right? All right, so now what do? I have to make another big 0, right? Let's add in here big 0 using add or subtract. That reminds us how we get our big 0. Okay, so I have another big 0 I'm going to have to make, but it's not with the letters this time. It's with the numbers. It's with the numbers. I have to figure out how to big 0 this positive 9 over to the positive 11. How am I going to big 0 that positive 9 out of there? Subtract 9 from both sides, yes. So subtract 9 from the positive 9, subtract 9 from the 11. Okay. Okay, so this says 9 take away 11. No, it says 11 take away 9, right? And I got my big 0 that happened right here with these 9, so I get to cross them out because they're all gone. Okay, 11 take away 9. What do we get? $11 take away 9. What do we get? Two equals what's left on the other side after we big 0'd the 9 out of there? What's left on that other side after we big 0'd the 9 out of there? What do we have left over there? The 3x, yep. So I have 2 equals 3x, and that's okay. Now we're done with all of our big zeros. All of our adding and subtracting is done. We're now going to go do the opposite, and this is actually just going to be the big 1, not big zeros anymore, because those are done. Big 1, how do we get the big 1? Using multiply or divide. Okay, so fix that. I need that 3x alone. The 3x is there. I need just an x. I need to big 1 what's with the x. So what's with the x right now? What's stuck on our x? The 3. So we have to undo stuck on. So is stuck on multiplying right now or dividing right now? If I say 3x, is that meaning multiplying or dividing? It means multiplying. So we have to big 1, so we have to undo multiplying. So what are we going to do to undo multiplying? Divide both sides by 3. Exactly. So on my left-hand side, I have 2 divided by 3, and that's going to equal, oops, got to go off keep forgetting to do that arrow, equal the 3x divided by the 3, because we got our big 1. Okay? No more 3 with the x. When we write our answer, the x's always go left. So final answer says x equals 2 divided by 3. And fractions are fine. Fractions happen. Fractions happen a lot in life. Only trick is we now have to go check our answer. We have to check our answer. And fractions make checking the answer a little irritating, but not impossible. Okay. I am going to change my font smaller for my check because I got to take that 2/3 back into my original problem, and it's up there and it's a pretty big original problem. So 5 over 1 times 2 over 3. Okay. I substituted the 2/3 into the x, plus 2 over 1. Now, all of them are turning into fractions because our x was a fraction. Okay. All of them are turning into fractions because our x is a fraction. Okay. 2 over 1 times 2 over 3. Because we want our whole thing to all look the same. We want fractions all the way. Equals 3 over 1 times, oops, I keep forgetting, times the quantity of 2 over 1 times 2 over 3. That should be a 1. So all of this is turning into a fraction stuff because our answer was a fraction. Our answer was a fraction, so we have to work with fractions. Let me make this a little smaller. Oops, I had one too many 2 over 3s in there. Okay. And then in that parentheses was a plus 5 over 1. And outside the parentheses was a minus 6 over 1. Okay. So I went ahead and I took that original equation and I stuck my 2/3 into each spot that said x. Okay. Everywhere there was an x in my original problem. So there was 1, 2, 3 places where there was an x. And there's 1, 2, 3 2/3 that we put in. All of them got filled with an x. Okay. So now we have to go ahead and clean this up because it's a lot of mathing. So 5 over 1 times 2 over 3 would be a 10 over a 3. Top times top, bottom times bottom. My 2 over 1 is still a 2 over 1 minus 2 over 1 times 2 over 3 is going to be a 4 over 3 because top times tops plus bottom times bottom times bottom. Okay. When we're multiplying, it's just straight across the top, straight across the bottom. We don't have to worry about common denominators yet. It's coming though. Equals 3 over 1 parentheses. Now we got to deal with this inside. That's still a 4 over 3, but it has to add a 5 over 1. And then we have to subtract a 6 over 1. Okay, now the problem that we have is that we need to have common denominators now because we've done all the multiplication we can, and we can't combine things unless they're in common denominators. Okay, when we're adding and subtracting fractions, we have to have a common denominator. So that means that all of them are going to be over the number 3. We need all of them over the number 3. Okay. So we're going to have to multiply pieces of it so they're all over the number 3. Okay. Got to multiply pieces of it so they're all over the number 3. The first one is already over 3. So 10 over 3, we're good. But is 2 over 1? That's not over 3. So what do I need to multiply both the top and bottom by? So a 2 over 1 becomes something over 3. Okay, there's going to be a 3 on the bottom. What's going to be on the top? If I multiply the bottom times 3, then I have to multiply the top times 3. Okay, if I multiply 1 times 3, I get 3, right? So now I need the top. I'm looking at this 2 over 1. I have to multiply the 2 times 3. So what am I going to get? 6. Okay, so making common denominators, you have to multiply the top and multiply the bottom to create the denominator you need. And in this case, it's 3. Okay, so I have a minus 4 over 3. He's over 3 already. Yay. I have a plus 9 over 1, but I need it to be something over 3. So if I'm multiplying the 1 times 3, I have to multiply the 9 times the 3. So what am I going to do? What is 9 times 3? What is 9 times 3? $27. Okay, so we have a 27 over 3. That's all that side equals. My 3 over 1, I can leave it for a moment. My 4 over 3, I can leave it. It's already over 3. The 5 over 1 is not an over 3 though. What do I need to do to turn that into an over 3? What am I going to say? What over 3? What over 3? What over 3 is the same as 5 over 1? What over 3 is the same as 5 over 1? $15 over 3 is. And we have to subtract. A 6 over 1, we can't keep it. We need to turn it into something over 3. So what over 3 is 6 over 1? What over 3 is the same as 6 over 1? $18 over 3. Okay. So now the reason why I didn't fix that 3 over 1 is it's multiplying. So it's going to be changing on its own. Okay, we didn't have to worry about it because we're going to be changing it on its own when we do that multiply. Okay, we're pulling together everything. We have a 10 plus a 6 minus a 4 plus a 27. Those are all my tops. And all of that is over 3. Okay. On the other side, we have a 3 over 1 times a 4 plus a 15 that is over 3. And we're subtracting an 18 over 3. So what is that 4 plus 15 over 3 going to really get us? How can we combine the top of the first side. So 10 plus 6, what do we get? Because that says 10 plus 6. What's that? 16. Taking 4 away, but adding 27 back. Three over 1 times 4 plus 15, 19 over 3. Okay. Are they all going to be this complicated? No, don't worry about that. But it's better to have a complicated example and have easy homework than the other way around. Okay, so now we have a 16 take away 4 on the top here. So what is my 16 taking 4 away? What is my 16 taking 4 away? So 12, and then I have to add 27, and that thing is over 3. Equals. This says that I have a 3 over 1 times a 19 over 3. And I notice I have a big 1 right here. I have a big 1 right there. So what's left? 19. But if I do that, it puts me back to 1, right? And I don't want a 1. I want to have the over 3 still, because I have this 18 over 3 I have to deal with. Okay, so yes, that is a big 1 hiding in there, but we don't want to use him because we need that over 3 happening. So I need the 19 times 3. What is 19 times 3? Use your calculator. It's okay. What's 19 times 3? 57 over 3. And I see that I'm subtracting an 18 over 3. So now I just have to figure out what a 57 minus an 18 is, because I can do the addition part easy. What's a 57 minus an 18? What's a 57 minus an 18? 39. Okay. And I know a 12 plus 27 is a 39 as well. So we are super happy because we're finally done with this yucky fraction. Do I care that this reduces? No. Because to check my answer, I don't care anything more than, did both sides come out to be the same thing? Yes. Does 39 over 3 reduce? Yes. But do I have to worry about it? No. For my check, I have to just make sure both sides come out to be the same. Okay. For my check, I just have to make sure both sides come out to be the same. For my final answers, I have to make sure they're simplified form. But for my check, I only have to worry about it coming out to be the same on both sides. I do not care that it's simplified or not. Questions about that? Questions about that? So I know that was super complicated. It's okay. Life is complicated. Life is not always easy. Life is not always easy. And it's okay. Doesn't make us less than, doesn't make us more than, doesn't make us anything but human. Okay. All right. So now we're going to go to our second answer. Example, I mean. Okay, we're going to go to example 2. Okay, so for example 2, we have 4 parentheses 2x minus 6, close the parentheses, plus 5 parentheses 3x plus 4, close the parentheses, and that has to equal 8x minus 21 plus 10x's plus 2. Okay, like I said, the steps aren't drastically different than yesterday. They're the exact same steps. It's just more complicated looking. There's a little bit more we have to do. Okay, according to our rules, first things first, we have to combine like terms. So that means we always look for sides that have more than one x showing or more than one number showing. Which side, not parentheses, which side is a string of more than one x, more than one number? The left side or the right side? Left side or right side? Has a string that's more than one x and or more than one number? No, not parentheses, a string of numbers. Okay. A string of numbers, no parentheses, no nothing, just a big long string of numbers and letters. Left side or right side? So remember, our right side is the one we write our hand with. Our left side is the other one. So it's the right side. This 8x minus 21 plus 10x plus 2, that's a big string of stuff. Okay, so we need to deal with that first. We have a positive 8x with a positive 10x that we need to pull together. And we have a negative 21 with a positive 2 that we need to pull together. That has to be handled. Okay. And when we get to the other side, we have those parentheses. Those parentheses are called distributive, not combined like terms. Okay. So distributive are the ones that we have to multiply the outside into the problem. So that 4 is going to multiply times the 2x and the negative 6. And this 5 is going to multiply times the 3x and the 4. Okay. So we're going to be doing both of those. And then we're going to clean up that right side. Both of those, and then we're going to clean up that right side. So, if I'm going to go ahead and do this, this says 4 positive times a 2x. What's a positive 4 times a 2x? What's a positive 4 times a 2x? An 8x. And then a positive 4 times a negative 6. Positive 4 times a negative 6. What sign is it going to be? No, negative and then 24. And then we have a positive 5 times a positive 3x. So we have a positive 5 times 3x. What do we get? 15x. And then we have a 5 times a positive 4. So what do we get? Remember signs. We need our signs. What sign is that 20 going to be? Okay, positive 20. Okay. Now we have an 8x that's combining with a 10x. Are they the same sign or different signs? An 8x with a positive 10x. Are those the same sign or different signs? Same sign. So we're going to combine them. 8 plus 10, 18x. And then we have a negative 21 and a positive 2. Are those the same sign? Are those the same sign? Negative 21 with positive 2? No. So what are we supposed to do with that when they're not the same sign? When they're the same sign, we get to add them up and keep that sign. But if they're different signs, what are we supposed to do? If they're different signs, what are we supposed to do? I have a negative 21 and a positive 2. Those are not the same signs. So what am I supposed to do math operation wise? And how do I know what the final answer is going to look like? When they're not the same sign, what math operation do we do? Do we add them or subtract them if they're not the same sign? We subtract them. And then how do we know what sign the answer is going to have? How do we know what sign the answer is going to have? From the bigger. Okay, so for this situation, what sign is our answer going to have? Negative 21 and a positive 2. What's our final answer's sign going to be? What sign is the final answer going to have? Negative. And then 21, take 2 away. 19. We don't say negative again because we already put the sign in. Okay, so put the sign in and then do the subtracting part. Separate them from each other. Okay, because if I said a negative of a negative, that changes everything. Okay, so we already had put this negative in, so we don't want to say then negative again. So I see on this right hand, the left hand side now, I have things I have to combine. I have a negative 24 that I've combined with a positive 20. I want the negative to show. Maybe I'll try again. Negative 24 with the positive 20, because those are the same kind of things, no x attached. And then the positive 8x with the positive 15x. Okay, so we're going to go combine those. We're leaving the right side alone. It's done for now. So I have a positive 8x and a positive 15x. What is that? Positive 8x and a positive 15x gets me what? Positive 8x with a positive 15x gets me what? Since they're both the same sign, what are we supposed to do? Different signs we subtract. Same sign, what do we do? Because that's a positive 8x and a positive 15x. Those are both the same sign. We add. Add to make what? Positive 8x plus positive 15x makes what? Positive 23x, not 23, 23x. Okay. Then we have a negative 24 and a positive 20, not the same sign. So subtract, keep the sign of the bigger. What's our answer? Negative 24 with positive 20. What's our sign and what's our answer? We're going to subtract. What's our sign going to be? negative, and then subtract 24 minus 20 is 4. Okay. We now have both sides as cleaned up as they possibly can get. So now is when we're going to go ahead and we're going to keep our balance and find our zeros and then find our big ones. Okay. Finding our big zeros and finding our big ones. To find our big zero, we move the smaller variable. Who is smaller in our variables? What am I going to do to move that smaller variable? Which one is smaller for my x's? Which one is smaller for my x's? So we're looking at the 23x and the 18x. Those are my x's. 18x is smaller. So what do I need to do to turn that 18x into the big zero? Subtract what? 18x. Okay, so we're subtracting 18x from the 18x. Lined up. And we're subtracting the 18x from the 23x because those are the same kind of things. We're not subtracting it from the 4, we're subtracting it from the 23. Okay, so 23, take away 18. What do we get? 23x, take away 18x. What do we get? Yep, 5x. We still have the minus 4, equal sign. What's left? I made a big zero of these 18s. So what's left? Negative 19, exactly. Nice catch. Do not say negative, don't say 19 because there's a negative sign in front of it. Okay, don't forget your negatives. Don't forget your signs. Okay, I need the 5x all by itself. Okay, I need the 5x all by itself. I need to move this negative 4 away over to the negative 19. How am I going to turn that negative 4 into the big zero? How am I going to turn the negative 4 into the big zero? Be specific. How am I going to move that negative 4 into a big zero? Add 4 to both sides. Yes. So add 4 to the left. Add 4 to the right. We got a big zero. What's left on the left-hand side? What's left for the left-hand side if we big zeroed the 4? What's still there, even though we got the 4 out of there? No. What is still on the left side, even though we got the 4 out of there? 5x. Okay. So 5x is going to equal, now we have to do the math on the right-hand side. I have a negative with a positive. So what am I going to do? I have a negative with a positive. So what am I going to do? What's my rule say when I have a negative with a positive? Subtract and keep the sign for the bigger one. So am I going to be positive or am I going to be negative? What's the sign on the bigger one? Negative. Okay, so negative and then 19 take 4 away. 19 take 4 away. 15. Okay. So I finished with my big zeros. I'm creating my big ones. Okay, I'm creating my big one. What am I going to do to create my big one? What do I have to do so the x is completely alone? What do I have to do so the x is completely alone? Divide by what? Yes, we have to divide by the 5 because the 5 is what's with the x. We don't want the 5 there. So we have to take a 5x divided by a 5 once we get our box. What are you doing? Thank you. The 5x divided by the 5 has to equal, equal the negative 15 divided by the 5. I made a big one. I get to cross it out. I have just left an x that's equaling what? What's that x equal? Is it positive or negative? It's negative. 15 divided by 5. Okay, 3. Yay, this one's cleaner. But we have to take that back up here to our original problem, put that 3 in, and see, did it work out? Okay. So I'm changing, there's 14. Okay, so everywhere I see an x in the original problem, I'm replacing it with a negative 3. So the 4 parentheses 2 parentheses negative 3, because there's my first x, minus 6, close it, plus 5, open, 3 parentheses negative 3, plus 4, close it. Let me make this a little smaller. Has to equal an 8, times a negative 3, minus a 21, plus a 10 times a negative 3, plus a 2. And we need to move him so we can work with him. So we got to make him smaller. Okay. And then I'm going to put it up above. Give me a second. So I took that negative 3. I put it back into my original problem. Everywhere I saw an x, I replaced it with negative 3. So the first piece says 2 times negative 3. Right there. 2 times negative 3. What's 2 times negative 3? What's 2 times negative 3? It says 2 times negative 3. So what is 2 times negative 3 equal? What's 2 times negative 3 equal? What's 2 times negative 3 equal? Negative 6. And there was a subtract 6 in parentheses with it. And there was a plus 5 outside. We open the parentheses. This says 3 times negative 3. What's that? What's 3 times negative 3? Negative 9. And in parentheses with it was a plus 4. And we close that one. And that equals an 8 times a negative 3. What's that? 8 times negative 3. What's that? We're working on the right side. 8 times negative 3. Negative 24 minus a 21 because that was already there. 10 times negative 3. Negative 30. And the plus 2 was already there. I have to clean up my parentheses now. I have a 4 times. This says -6 with -6. That's the same sign, so I get to add them up. It's a negative what? -6 with -6 makes what? -6 with -6 makes what? -12. Exactly. Because they're the same sign. We add them and keep their sign. So -12. Oops. Don't want two negatives, just one. And then I have a +5 with, I have to clean up the parentheses, -9 with +4. -9 with +4. What do we get? -5. Okay, and that equals, now we're going to clean up this side. This says -24 with -21. So what do I get? -24 with -21. So what do I get? 24 plus 21. It's negative, yes. 24 plus 21. 45. And then we have a subtracting 30 and a plussing of 2. Okay. This says -4 times -12. What do we get? 4 times -12. What do we get? I know it's negative because there's only one negative. 4 times 12 is what? 48. And then that says +5 times -5. So I know it's negative what? 5 times 5. 25. So right now I only have like 3 people that are getting participation points, but that's okay. It's your choice. Okay. Now on the left side, on the right side, it says -45 with -30. What is that? No, it's -45 with -30. -75 plus 2. Okay. Now, the left side says both are negative. That means I'm going to add them together and keep that negative. So it's a negative what? 48 plus 25 what? What does that give me? -73. Okay, so I got a -73 on the right, on the left, and I have a 75 that's negative and a +2. So that's still going to be -73 again, because 75 minus 2 and negative was on the bigger one. Okay, so I got it to work out that both sides are the same. So x equals -3 is my final answer for that. So these are the same as what we were doing yesterday. They just got a little more complicated. Takes them a little longer to get done. Okay, this is our last one. -6, parentheses 2x plus 8, close it, -9, open it, 9 subtracting 6x, close it, equals 3, open, 2x minus 5, plus 6 is on the outside. Okay, I do not see any combined like terms because I do not have any string of numbers and letters, okay? But I do have distribution, okay? I do have distribution. I do have to do this -6 times the 2 and the -6 times the 8, the -9 times the 9, and the -9 times the -6, the +3 times the 2, and the +3 times the -5. So we got to go handle the distribution stuff. That is going to give us a string that we're going to have to combine like terms on, but we have to do this first. Negative times positive, I know my answer is negative. 6 times 2 is what? 12. Okay, and I have a -6 times a 8, so that's negative. Oops, there's an X on this, it's 12X, sorry. I have a -6 times a +8, so I know my answer is negative. 6 times 8 is what? 48. And then I have a -9 times a +9, so I'm negative. 9 times 9. 9 times 9. What do we get? What's 9 times 9? Oh, 81. And then I have a -9 times a -6. Negative times negative makes what? When we're multiplying, same sign gets us a positive answer. So that's a positive answer of 9 times 6x. What is 9 times 6x? 54x. Other side of the equal sign now. I have a 3 times a 2x. What's a 3 times a 2x? 6x. And I have a 3 times a -5. So what do I get? -15. And I still have that +6 that's on the outside. Okay. So now we got to go clean up. Now we have combined like terms because there's a string. We have a -48 with a -81 we've got to clean up. We have a -15 with a +6 we need to clean up. And we also have some variables that have to clean up. A -12 with a +54 has to clean up. Okay, so we have a couple things to clean up. Letters come first. So +54 with -12, subtract, keep the sign of the bigger one, so that means positive. 54, take 12 away. 54, take 12 away. What do we get? 54, take 12 away. 42. X. Then we have the -48 and the -81. Same sign, still negative. How much? Oh, I have good news. We're going to fix a typo. There should not be a -9 here, just a negative. So this is just -9. And this is just +6. Oh, praise God. Better. We like that better. I apologize. I just looked down and noticed. -12 with +6 is -6x. Sorry about the typo. Sorry if it's messing up with our heads. I have a -48 and -9. They combine to be what? 48 and 9 combine to make what? Use your calculators, guys. It's fine to use your calculators. What is 48 and 9 get us? 57. Thank you. All right. I apologize for that mess up that made it a little weird to look at. I'm going to fix my shading here so it's more accurate, because once I took stuff out, it misaligned things. All right. We have to go to the other side. The only thing we need to combine is this -15 and a +6. Those are not the same sign. So we're going to be subtracting and keeping that sign. The 6x is still there. What's the sign going to be? Subtract and keep the sign on the bigger one. So what's the sign going to be? I already assigned the delta math last night. Yeah, there's delta math. Okay, sign's going to be negative. Thank you. Negative what? -9. Thank you. -9. All right. Now we get to, whew, that's done. We've combined our like terms. We've done our distribution. We're making our big zeros. We're making our big zeros. When we go to make our big zeros, we always look at letters first. So I have a -6 and I have a +6. Which of those is bigger? Which is bigger, a -6 or a +6? +6 is bigger. So we have to move the smaller. I have to move this -6. How am I going to turn a -6 into a big zero? What am I going to do? Add the 6x. Yes, plus 6x to both sides of the equal sign. Whatever we do on the left, we must do on the right. Whatever we do on the left, we must do on the right. It makes a big zero on the left. The x's are now gone. What is still there? Don't want this one, want this one. What is still there? Once the x goes from the left-hand side, what's still there though? What did we leave behind when we moved this x's out of there? On the left-hand side, the -57 is still there. Yep. Okay. Now we look at the right-hand side. The right-hand side says 6x plus 6x, so that makes what? 12x. And the -9 is still there. Okay, now what? Another big zero has to get made. We need this -9 to go. We need that -9 to go. We have two numbers now and not two letters. This -57 and this -9, we need the -9 to become a big zero. So what are we going to do to make a -9 turn into a big zero? We're going to add 9 to both sides of the equal sign, because whatever we do on the left, we have to do on the right. Whatever we do on the left, we have to do on the right. Okay, so now the left side says -57 and +9. Not the same sign. So what are we supposed to do? When they're not the same sign, what are we supposed to do? They're not the same sign, so what are we supposed to do? -57, +9, subtract and keep the sign of the bigger one. So what are we going to get for our answer? -48. Thank you. -48 has to equal 12x. All right. Did we finish all our adding and subtracting? Have we made all of our big zeros? Are those all done? Do we see any more adds and subtracts? No. So we're all done with that. Our last big zero was right there. So now we have to go for the big one, right? We have to go for the big one. We have to get the x all by itself. What are we going to do to get the x all by itself? No more number for the x. What are we going to do? Yep, divide by 12. So -48 divided by 12 has to equal, oops, I keep forgetting that, has to equal a 12x divided by 12. My big one appeared, right? My big one appeared. If I could grab it. Okay, I can now cross off what's with the x. I now only have x left, and x always comes first. So my x equals, what's negative 48 divided by 12? Negative 4. Because there's one negative, so its answer's negative. Okay, 48 divided by 12. So I have to take that negative 4 up into my original problem. So I'm going to go up here. Start it up here. I had a negative 6. I put in a 2 times a negative 4. And I have a plus 8. There's that first parentheses. Minus the parentheses of 9 subtracting 6 times the negative 4. And that has to equal 3 times 2 times negative 4. Close that one, subtract the 5. Close that one, add the 6. Change the size of the font because it's too big for what we want. So I didn't do anything new. I just replaced all of the x's in my original problem with that negative 4 that we just solved. Okay. Now we have to go start doing the math about it and cleaning it up and getting rid of parentheses and making it simpler. So negative 6. I have a 2 times a negative 4. What would that be? What's a 2 times a negative 4? A negative 8. And then I plus 8. That's that parentheses done. Minus. I have a 9 subtracting. Or am I subtracting? I have a negative 6 times a negative 4. Is that subtracting? Negative times negative makes what? Negative times negative makes what? Positive. Okay. Positive 6 times 4, 24. And it equals 3 times. There's another negative 8 because the 2 times negative 4 did not change, right? And I had the minus 5, and I'm adding 6 after. Now, what is a negative 8 with a positive 8? That's what that says in that first parentheses, negative 8 with a positive 8. So what is that? What's a negative 8 with a positive 8? 0. Okay. And then we have a subtracting a 9 plus a 24. What's that? It's a 9 plus a 24. $33. Okay. And it's going to equal other side 3 times negative 8 with negative 5. So I know the answer is negative 8 plus 5. Eight plus 5. 13. And I still have that plus 6 tagging along at the end. What's anything times 0? What's anything times 0? Still 0. So do we have to add and subtract a 0? No, that's why we make a big 0. So I just have negative 33. That's all there is left on that left-hand side, right? Because 0 times 6 is 0. So that would say 0 take away 33, and we don't need it. Okay, what's 3 times negative 13? I know it's going to be a negative. 3 times 13 is how much? 39 plus 6, not 5, 6. Okay. Left-hand side, still negative 33. Right-hand side, negative 39 with negative 6. 39's bigger and it's negative. 39 takes 6 away, 33. Yay! It checked out. The final answer was negative 4. The final answer was negative 4. Yay. Okay, done or not, turn your notes in. As long as you're having and doing at least 75%, you are still getting full credit for that. Because I know some people don't write as fast as others. So turn your notes in, done or not,